Hello, Rumale sir.
Hello,
Shall we
madam.
start? हाँ sir, shall we start?
हाँ,
Okay sir, okay. Uh, Good morning to our respected expert, Dr. S Rumale sir, and all participants. I, Professor Dipali Sananse, welcome you all to online short-term training program on recent trends in artificial intelligence and machine learning, organized by Department of Computer Science and Engineering of JDIET, Yavatmal. We have Dr. A.S. Rumale sir as an expert for today's first session. I would like to introduce our today's expert. Sir is currently working as a professor at Sandeep Institute of Technology and Research Center, Mahiravani, Nashik. Sir has 25 plus years of teaching experience. Sir has published 40 plus research papers and 4 plus books. And also, Sir has one patent and copyright on his name. Sir has his own YouTube channel. Sir has his own course on machine learning on Udemy. Sir has completed 90 plus FDP certification in IT. Also, Sir acted as a resource person 50 plus times. So now I request Dr. S Rumale sir to take charge of today's session.
thank you, madam. Very
Yes, sir.
welcome all the viewers and listeners to this session on heuristic functions and decision making in AI. I have not made the presentation in a way you generally habitual of. Just 4 slides are there. The first is title and last is thank you, and in between the 2 slides are there where we are actually going to discuss the things, and based on those discussion, and you can say the interactive session, that is a few questions will be asked from my side, and a few questions will be asked from your side, and we will try to come to a particular answer to for those questions, and with that we'll go with the next what you can say step of what is meant by the heuristic function. So let's see what is heuristic function. So if you go with the heuristic, what is heuristic? This we have to first identify. I'm writing something here on this board using a pencil. Is it visible to everybody?
Yes, sir.
Yes, sir.
Okay. Because this writing we we are coming, so at the time of discussing we are going to show this. So what is heuristic? Mostly when we do many type of things, like say uh, doing something, say suppose I want to go from one place to another place and I don't know the road or something, we generally use what we call as a gut feeling. Okay, or we many times only use the coin to toss. So say suppose you are having the coin, one coin is here, this is the part, that is we can say head, and let's say the next part that we can have the tail, and we decides our next move based on what these coins are going to give. If they give the head, we'll say move say toward left, and if they give the tail, we move to the right. So here there is no logic at actual, because whether it is head or tail, it actually have no correlation with moving towards left or right, but still this gives us a trigger in making a decision. Okay, so purely actually speaking, this is the heuristic completely, where sometimes the logical mathematics stop to work. We need to take the decision in a fuzzy way or illogically, and that is what we call as a heuristic. So this heuristic is one type heuristic, or we generally know this as a random number generation. For example, let's say suppose I want to do some search on the n number, and say suppose these numbers are minus infinity to plus infinity, means you are having here no numbers at all, that is your two small number and a very large number, so plus infinity, this is what your the range. Now if I ask you to consider the mid of this line, what will be the mid? Any one of you? Hello listeners, participants, to know this very basic concept of decision making in AI, because in automation, in control area network, in robotics, in everywhere, this basic is actually used, the heuristic function. So I like to get some interaction from your side. So just answer the question. If you are given with the range minus infinity to plus infinity, where you will get the mid? You know that balance curve, bell curve, where we are having something like this, and we know that mean, median and mode need to be equal to have this curve very bell curve very complete. So what is your answer to this?
Sir, I think mid will
Yes?
be 0.
No. We generally, when say we say 0, actually to find out the mid of this is the formula of average, that is minus infinity plus infinity, and then we divided it by the 2. Okay, but you don't know how many numbers are there, so it is not actually get divided by 2 but the infinite number. Okay, so 0 is not the answer of mid, because you don't know what is plus infinity actually and what is minus infinity. So any number, any position, even if I say that this position, this is called as a k. So this is called as a random selection. You know, that is in a pivot value to do the something what we use in a divide and conquer method. Okay, so mid is actually identified. Okay, 0 is the mid when you are in the mean, median and mode all are equal. Then at that time you get the 0 as a mid. Otherwise you require this k. And this random number selection is done without any logic. Without any logic. For example, if you go with a quick sort, a simple example, quick sort, it actually try to define the pivot with which they can sort the element, and so any element can be a pivot, or an element which is just not fit into the given list may be the pivot, and we compare the element with that and we get the sorted result. So generally the heuristic is something, okay, where we use something which is not literally explainable with the words properly, but you can, if you put it into a very uh, plain way, you can generally give the answer very correctly. So heuristic is simply that. For example, let's say suppose in last year we got rain in the month of June. So we say that whenever there is a June, there will be the rain. So this is our past knowledge. It's not always going to be true. Say suppose today while walking on the road, if you see a blue car, it's not necessary that you will see the same car tomorrow if the car is not of your neighbor. Okay, but we can say that if there is a neighbor and he is having the blue car, the possibility of seeing the blue car whenever you come out of your house is more, and that is what we call as a heuristic. So heuristic is a plainly speaking a probabilistic function. First, it is completely fuzzy. So the probability is something like, for example, let's say suppose you are having a tree. I'm giving these examples for this because to know first what is heuristic we require to give. And this tree is having 100 birds on it, and one what you can say person fire to this tree, and how many birds will remain on the tree. The plain mathematics say that if the one bird get shoot by the hunter, 99 birds will remain on the tree. Plain mathematics. But that is not the answer. In artificial intelligence or machine learning, we require here the probabilistic or fuzzy logic. So here we go on doing the behavioral analysis of the object, and we consider the object also respond to the whatever action happens with that object, and so it depend on that you get the heuristic, and you say that there is a fear of life, so no bird will remain on the tree the moment it just heard the sound of that bullet, and here this is the heuristic. Another heuristic is the function. This heuristic is, or this is called the fuzzy logic. But there is also a thing that is not all birds simply flew away from the tree. They will simply flew away for a while from the tree and may return back. So what is the possibility of the number of birds which will return back immediately after the shootout? Okay, that finding is again the probabilistic. You don't know exactly, but still here we can go with a random number or a heuristic number, and that is what we call as a heuristic. So heuristic is something when we consider there. For example, let's say suppose if you are having a simple vehicle here, I am now giving the example of robotics, and this is having the camera. Now this camera is fixed on this particular position. Now this camera know this position, and how this vehicle come to know that it is going forward or reverse. So this will have a complete memory here, and for every movement, so whenever is go in a direction towards the camera, okay, we call it as a forward movement, but the every moment, that is every frame, for this is the frame of the picture at time equal to t 1 second, and this is will be the frame of the picture at a time equal to t2 second. Now this t2 minus t1 actually gives the difference to this camera. Now if you go with this as a distance like a p, okay, and if you consider this as a q, and if we try to find out this distance, so we know that is this q is always greater than p if it is go in a forward direction, and p is always less than q if it is go in a reverse direction. So the outcome of p minus q in a forward direction will be negative, but in a reverse direction it will be positive, because you are going from q to p. Q is larger than p, so you will get that way, and that solution that actually adds here in this machine to find out the things. For example, when we have the rover on the moon, okay, and try to find out the differences or the moment, the whole and everything, what it is using is the heuristic function. But now this heuristic is calculated. This heuristic is calculated. Now, first is that by gut feeling means random number generation that we are doing in our computer engineering lot of a time, and because these random numbers are not purely random numbers, so we call it as a pseudo random number. So the first thing is that the heuristic function, which is generally by default shown as h of n in the uh, artificial intelligence algorithms and something, the subjects, this heuristic function h of n, these are of three type. First is purely random. Purely random means there is no equation at all for it, so it just happens. That is what is the pivot value that you have to select. So we can select pivot value, okay, randomly any value. Okay, you can say that is p equal to random number generation, and that's okay. Or you can say pivot value equal to the number of elements divided by 2. So whatever the element we get index, that will be the pivot value, that is h of n. Another h of n is probabilistic. What is the probability of having this? So when you say you go with the probabilistic heuristic, we generally call it as a logistic or logistic regression. Okay, where we try to find out whether something is in this class or not. So that is based on the similarity index. Now you know that Hamming, the student of computer engineering who are called working on the communication data, he come up with an Hamming distance formula, and that formula actually generally called in image processing or in artificial intelligence as sum of absolute differences, or SOD formula, where it takes the status of any object at a particular time. Say let's say t1, this is as a t2, and whatever the difference between this t1 and t2, if you take the modulus of this, we get, or you can say the perfect mod of these things, we get the positive outcome, and that positive outcome actually gives us the answer. So that one is there. And then this is the completely Pythagorean, what you can say, the third part of the h of n, where we actually calculate the heuristic in heuristic value to get the answer. Now, how it help in decision making? Just I'm just giving you one thing. Let's say suppose this is the state, first state of your existence. Okay, that is you exist at time equal to t, and you are having one apple. Okay, you are having one apple, and what say you saw the friends, two of your friends approaching to you. So what are the possibilities that you have? We are going with the logistic. You can share the apple with your friends, or you won't share the apple with your friends. Now how you will going to get the decision? A trigger should have to be there, that is heuristic. Now what will be the trigger? You know your friend's habit, okay, you know your own mentality, and that summation, okay, so your mentality plus, when I am saying your, I am also included, because if the apple is with me, this you is actually me, and say suppose you are my friends, whether I want to share with you or not. Okay, that is the question. And then you are having the friends habit. So these two things, you and your friends habit, these two things, they are actually qualitative in nature, but we consider this in terms of quantitative in nature, by saying that, say suppose you don't like to share, this is your quality, and your friends always like to take something from you, this is your friend's quality or habit. Okay, so now you don't like to share, if you give the weightage to this as a 1, and because you are in the two friends or more than one friends, this is, say suppose you got the three friends, who will win? If you compare there, who will win? Whether your quality will win or your friend's quality will win. Hello, am I audible?
Hello?
If your friends, I
Hello, sir.
who will win this here? Obviously the friends will win because they are having the if you scale these qualities on 1 or 2 or like this, your friend are having the 3 and you are having only 1. Okay, so you know that if you resist to share, you may not get the proper share of the apple, so you will say okay, let's divide it in 4 parts, at least you will get 25%. And this is called as a heuristic. And what this is called as, this is a decision making tree that we are making, and we are using the heuristic function where we are using the attributes or dimensions or features. We use dimensions or features to communicate with the different uh, what we can say, with the different things. So different decisions, to make the different decisions, so we try to match the features. Okay, so you know that is you do not want to share is your feature, and you weight this feature on the scale because this is a qualitative feature. You made this into scale and do not want to share is having the weightage 1. Okay, so 9 times you will like to share with your friends, and you are having the n number of friends and they want to get it from you, and that is, say suppose you are having here 3, n equal to 3, so this 3 is bigger than this 1. So to save yourself from the loss, you will share the apple. Now this apple will be divided into 4 parts, so you will get a 25% of it. And this is what decision making. But this decision making uh, actually come here with a triggering point, and this triggering point is called as a similarity index. This is a heuristic. So generally heuristic function or heuristic works on the similarity. Means last time something happened to me, when particular object was there, the same thing is going to happen with me if I repeat the procedure in future with the same object. Means let's say suppose say 2 years back, if you touch the fire by bare hand, you get the burn. Today, means 2 years after, if you touch the fire, you will still get the burn. Yeah, so this is what we call as an heuristic knowledge or heuristic function, and this heuristic function is based on the similarity index. You got this? Means understood? Or you have any question regarding this?
No, sir.
So this is a heuristic. Now, so heuristic actually help in decision making based on identifying the similarity. Now, when we say similarity index, and if you are in the two objects, the more similar objects are gathered together. More similar object gather together. Let's say suppose these objects are gathered together here, and these objects are also gathered together here. Then we can call this as a SVM, support vector machine. We also call this as a classification. Okay, so if you are using heuristic properly, if you using the heuristic properly with a very less computation, only by matching the features, okay, proper feature extraction is needed, and for that, and proper feature selection. Obviously if you select the proper features of a particular object, okay, then you can compare with those features the different objects. For example, what is the feature of this object here? If I draw the circle, it have the center, and you know pi r square is the proper feature to represent a circle. So anything which satisfy the pi r square, whether it is of the same size, of the small size or large size, will fall in a same class because they satisfy the one functionality or one feature, and that feature pi r square is here the heuristic function. It is a pure or absolute mathematics. So when we say heuristic, it actually makes us making decision. We as a human being can identify a circle very easily, but for computer to identify it, it required to find out the edges, everything, and then you have to compare the things in terms of the distances. And so the heuristic function is all about identifying the distance, or distance means the difference between two things. Distance also means the similarity between the two things. So when you find that there are similarities between two things, you can say, okay, they are of same type, or they are of similar kind. So you can classify them, you can do this. And so what is the role of heuristic or decision making in artificial intelligence? This again, the question that we require to discuss in terms. Okay, now I'm going to discuss this using the example of conveyor belt. Let's say suppose you are having the conveyor belt, and this belt is loaded with the objects, say one object, second object, then you are on the third object, and these objects are moving forward because this belt is having the rotor actually fixated on some rotatory motor. Okay, and one CCTV camera is here which is observing every object passing through this zone. So the frame size is fixed here. This frame size is say n by m. Okay, so whenever this object comes here on this position, this CCTV camera or this camera actually observed this, and that object was observed. Now how this object was observed? This object was observed by the camera using the heuristic, say image processing, but it uses the heuristic. A quality measures are given. Say suppose for a quality measure, a particular histogram quality is given to it. Okay, so it does what? It just creates the histogram for this new object and compare it with this. And when it compare this, you are having the new object as a P and the old object or the standard object as a Q. So you have to get the P minus Q equivalent to, actually not equal to, it's impossible, equivalent to 0. Actually not 0, 0 is very thing, when it's equivalent to epsilon. So if the difference between the object P and object Q is very negligible, it's near to 0, okay, very small than 1, you can say object is okay. So this is called as the industry select procedure. Robotics uses this P minus Q. So it creates every time things, it uses the Hamming distance. Hamming distance simply uses the XOR function at its very basic level. That is, it's say 1 plus 1 equal to 0, 0 plus 1 equal to 1. If the outcome is 1, it reject the things. If outcome is 0, it push the things in the next direction. If it is rejecting, this is push from the conveyor belt. If it is accepted, this is allowed to pass to the next process. So this is where the heuristic function is used. This is where the decision whether to make this object pass is made, and this is called as AI. When heuristic and decision making is done by the machine itself, we know it is artificial intelligence. Obviously this artificial intelligence is not the AGI, it's not the artificial general intelligence which can do everything. It is a particular or a weak artificial intelligence which actually work only on some particular domain where this can be used. For example, let's say suppose you want to pass a particular type of products, you created particular type of products in a industry, and these products need to be checked and done. So then this can be used here. Now which heuristic function is used here? The XOR function, or actually Hamming code or Hamming distance. Now if you see in machine learning is the basis. Data science, machine learning is the basis. Actually statistics, these are the basics for artificial intelligence. If you see the Hamming distance or Hamming code distances or Hamming code or sum of absolute differences method to find out what is the this role of this heuristic and decision making in artificial intelligence. You will find it is used to identify the object, it is used to classify the object, it is used to make the decision whether to move forward or reverse. For example, anomaly detection. If you go with a simple rate and here you are having the some obstacle, okay, or you are having obstacle like this, you are having it like this, and you are having your vehicle, uh, driverless vehicle. Now this driverless vehicle camera will see the differences. So for the plain road, every time it get p minus q is equivalent to 0. P minus q equivalent to 0 for this all this. The moment q came here, p minus q is non-zero. P minus q is non-zero. Okay, so it's how to find out p minus q is very larger than the epsilon. That is large than one. I say one or more than one. Then we can't call it as a non-zero. So it may be negative or it may be positive. In that case, it will stop there and it will try to find out the way out. This is what happened with the Chandrayaan Mohim, that our rover actually when found a trench there on the moon surface, it stopped and it tried to find out the way through to avoid that hole, okay, so that it can't fail into the hole. The same thing is used in the Tesla cars and everything, and the basic fundamental which is used here is the heuristic and heuristic function h of n. But the basic heuristic function used is here Hamming distance. Actually they use the different other things also, and based on that it makes the decision. So this decision is made very clearly and very simply for this p minus q. But what is the necessity if I want to get this p minus q here properly every time? The speed of the vehicle need to be constant, because the processors that we are having into the vehicles to compute the things, okay, if we go with the variated speed that a human being can do, our brain is very capable to do many computations at a time. Processors are not that capable yet, okay, so we require a constant speed. So generally the speed is kept constant, say k in this condition, so that when the constant is there you can drop it from the equation. When constant is there you can drop it from the equation and p minus q only remain. So that p minus q will give you the equivalence. This is a heuristic function calculation done, and to make it zero non-zero you generally uses the absolutes here. We generally uses the absolutes. Okay, so p minus q whatever there, if it is non-zero means it is, if it is larger than epsilon, okay, so we call that there is some anomaly, there is something which is where we require to consider the things. So if it is equivalent, we know that accept, equivalent to things, accept, is not equivalent, reject in on conveyor belt. Here if it is equivalent to 0 or epsilon, go forward. If it is not equivalent to epsilon, go reverse and try, and then either move to the lefts or move to our rights. Now where to move? Again the heuristic comes here. I told at the first session, the first part of this session, this conversation, that we generally take the decision by tossing a coin. When you come head, we go to left or go to right, and like this. No, but this tossing coin is very possible for us because we have the eyes, the brain and everything. But here in a computer or in artificial intelligence robots, these things need to be calculated properly. So where these things will be calculated then? So it will check the, if you have this, here you are in the hole, okay, and let's say suppose this is the left part and this is the right part of this machine, and here is your rover. So what it will say, it will take the picture of this, it will take the picture of this, okay, and try to find out the epsilon value. If the epsilon value is achievable, that is p minus q is 0, and it calculate it without moving. It calculate it without moving an inch, just by shifting the focus of camera. So camera focus is first at this position, second at this position, third at this position, fourth at this position, and sum of absolute differences of all these positions need to be equivalent to epsilon. Then it will choose that correct path. It not choose randomly but we can call it as a random because it actually not go for the complete tour. It's only consider a partial part of that path. This is what we call as a hill climbing algorithm or blind hill climbing algorithm. Okay, and this is the artificial intelligence basic algorithm where heuristic functions are used to make the decision whether we have to go forward or we have to stop, means we reach the goal or not. And this is how we can say. So what is the role of heuristic function in decision making? Heuristic functions are used as a basis. Heuristic functions are used as a basis for making the decisions. And based on the heuristic value, if it is 0 equivalent to 0 or if it is non-zero, if not equivalent to 0, or when I say 0 it is nearly epsilon, or you can call it as in congruence to 0, that is it is epsilon, it's a very smaller than 1. Okay, or p minus q is very smaller than 1. So when this difference is small, you say that okay, you can take the positive decision. If difference is very large, you say okay, we can take the another decision, like this. So this is how the heuristic is used in decision making. Now these many people actually many scientists, researchers classify these heuristic functions in our heuristic way into different availability heuristic, sense heuristic, this heuristic, that heuristic. I consider that heuristics are only up to 3 types. First is the random, where you don't have any initial seed to take the decisions. So the first decision that you are taking without any seed, what we call it as unsupervised learning. Okay, first decision that you make without any seed means you want to go somewhere. Let's say suppose you are on a bike and you want to go somewhere, and suddenly you got the bifurcation on the road. So which road you want to take, left or right? And you don't have any Google map, anything to help you. Many times in old days, people used to go just based on what we call say intuition. So they used to throw the coin, if head go left, if tail go right, like that. So that first decision which you are actually taking without any seed or with some pseudo seed is called as an unsupervised learning here, because nobody is there to direct you. Then who is directing you? The random number. That is first heuristic. Second is the acquired knowledge, past knowledge. That is second what we call as an heuristic function or heuristic, which helps in decision making. Let's say suppose when you go doing this, you have taken the left turn in your last tour and you got to the destination. Your brain actually registered it. Here the computer actually registered it, that is when it take the left turn in last position, it actually got the goal. So next time it try to go to the left position first. Okay, and there it may get the yes or may get the no. If it get yes, okay. If it get no, it reverse back. What is this? Reinforcement learning. So unsupervised learning becomes reinforcement learning when you have the past knowledge heuristic. Okay, you have some seed with you, some seed knowledge with you. Okay, and that knowledge you are using to take the decision. This is reinforcement learning. But now when the entire territory is known to you, you won't require to depend on the heuristic. You don't require to depend on the heuristic, because now the acquired knowledge The complete acquired knowledge won't require that computation. You know that when you go to the left, you get this, you go to the right, you get that, and everything. So in the entire travel, without making a mistake, you make the things. So heuristic require continuous learning. This is what we call. So generally the heuristic use in GAN, generative adversarial network, or which is called a very advanced branch of this artificial intelligence. You know about the chat GPT, you know about many artificial intelligence application where these heuristics are used, where they keep on learning, keep on learning the pattern to the level of perfection that the next time when it comes to make some decision or to do something, the AI system, the AI model don't need to do much of the computation. Okay, so if this is for the one function, I'm going to discuss everything here. This is, we are considering only for one function. Now if say suppose we go for the all function, or say k function maximum, k tasks. For example, if you go with a chat GPT, okay, chat GPT can do a particular type of work in a particular domain. But if you consider that you are having a different domain, that you can work at the same time, just like a human being, you can dance, you can write, you can sing, you can do many other things at the same time, you can think, and likewise. Now if you have this the many domains, you can have the heuristic function. Now such type of heuristic function are generally shown with star. Star stands for closer. You know that A star algorithm, K star algorithm. If you go with a chase, you have the Q star algorithm. All these star algorithm or star closer algorithms, which actually encompasses the complete set of the different complete set of different what you can say possibilities or domains of a particular object or the task object can do. Okay, then that is called as a AGI, artificial general intelligence, which is a much stronger, much faster hope from the human intelligence, because our brain have capable of doing many things, many wonderful things. Our brain have one thing, and that is it is biological, so it tears and wears. We may get the Alzheimer, but that is very rare, not impossible, but rare in case of the machines. So memory may get damage of the machines, bad sectors may happen there also, but still it can handle it very efficiently, and that is what we can say. The heuristic functions can be used for the decision making, and the role of heuristic functions in decision making is very important in artificial intelligence, because without heuristic you can't have the unsupervised learning proper, you can't have the reinforcement learning proper, you even can't have the what we call as the continuous learning or generative learning proper. So basis for all this starts with the heuristic. Okay, so do you have any questions, queries till now, whatever we discuss regarding that?
Sir, I have one question that can you please explain the difference between artificial narrow intelligence and AGI with any example?
Now, right now I have the artificial narrow intelligence that I just explained here, or is called as a weak artificial intelligence. This first you are in a unsupervised learning mode, okay, then you become what you can say in a reinforcement learning mode, and when you come to know everything about that particular domain, you are in a intelligent mode, but you only know about that domain. Outside this domain you are dumb. Means say suppose you are having a conveyor belt intelligence, which is capable to identify the incorrect object and can throw it away from the belt. Okay, so it go on learning efficiently, and it will become much efficient in handling this. But if you want to apply the same intelligence somewhere else, this intelligence is of no use. Means it is just like that, is you know the skill of cooking first, you take the measurement of all the ingredients, the by the day you become expert enough, you won't require to take the measurement and you always cook good. It happens, but you can't use that intelligence or that acquired skill into sewing domain, because there you require a different type of intelligence. So that is what we call as a narrow intelligence, a intelligence which actually solve the problems in a particular domain only. If it is not solving the problem out of that domain, that intelligence actually have no use, or it simply won't withstand the competence required. Now if you go with a AGI, that is what we call as a general intelligence, you are having the n number of domain. Means swimming is one domain, I'm taking giving you, walking is one domain, jumping is one domain, acrobat jumping is one domain. Okay, so if you go with all these domains at the same time, okay, then you can call this as the AGI. So generally when we say strong artificial intelligence or artificial general intelligence, or we call this as generative adversarial network, we are actually talking about the artificial intelligence which are capable to handle two or more domain at with the same efficiency, and we call this. Now if it is capable to handle more than k domains at the same time, such type of intelligence may surpass the human intelligence, artificial intelligence, and it may be beneficial to the human, or it may be hazardous to human, either for the existence or many other things. For example, let's say suppose if you are the artificial intelligence program which can read, write, do this everything, but is capable to do research also, just not writing the research paper, capable to do research, it require thinking. It is a very far actually expect a very high expectation from the current state of AI. But if it is possible, just like shown in these pictures of Avengers, that Jarvis and other thing, okay, in that case, that intelligence can do many things which human many petty things which we are doing, means doing some writing work, doing some cooking, doing some swimming, these, and we won't require to do those works like that. So this AGI is you actually the scientists are working on it. OpenAI CEO Mark Altman actually got fired by due to this AGI some conflicts, and if you go through and search on this, you'll find many details there regarding. But this AGI is considered by many scientists as a danger to humanity. They actually visualize in the movie of Arnold Schwarzenegger in Terminator, that the Skylab, like an artificial intelligent program generated, actually take the control of the complete machinery over the world and try to do the things. Just like it is obviously the speculation, but the AGI or the general intelligence is something where your artificial intelligence model or your machine learning model is capable to what you can say do many things at the same time, many things from the different domain at the same time. This is used in CAN. CAN is called as a control area network, which is actually used for driverless cars, driverless aeroplanes or something. Control area network mechanism, where the vehicle or the object is provided with eyes, means the cameras, and these cameras are attached to a very high end processor, also attached to the satellites to map the geo positions and everything, and it have its own intelligence to record the geo positions which are not you can say recorded into the satellites. For example, if your vehicle is on moon, you don't have any satellite service there to provide the geo position to that particular vehicle, then the vehicle actually try to create the map of its surrounding just by observing it. It is capable to do many things at the same time. So that there they are actually using the different domains, but these different domains are used in ensemble fashion. They are not used in a what you can say the completely mix or uh, what we call as a homogeneous pattern. It is ensemble. Ensemble means you put many things together and everything, all those things are acting independently. So it is still not the what you can say strong intelligence, artificial intelligence, but it is called as a narrow intelligence at that in that sense. But it is still what you can say the AGI, because it is capable to do many things at in different domain at the same time. If you consider the whole object as a one, the rovers and other things. So these are the things. For a say suppose if you go to the let's say suppose you created a chat bot, like a bot, actually not chat bot. You just created a bot. Bot means the software robot. Okay, now this robot bot for the share market, this robot or this bot is capable to watch the movements in share market, capable to take the decisions, capable to do trading, and capable to put orders and everything, and that again at friction of time means this bot is particularly very strong intelligent in that domain only. But now if you ask the same bot, if you apply the same bot say for the product selection in on Amazon or Flipkart, the bot won't work properly because it fails in that domain. So this is a weak intelligence. But now if the bot is just like you, means it can do the share market, it can do the WhatsApp chatting, it can do the things, means three different domain at the same time, or what you can say intermittently, we can call this bot as a AGI, artificial general intelligence. And if you are having the search bot, let's say suppose search bot is there in your mobile, okay, and it just want you want to call your mother on a particular time, you want to call your sister, you want to call your fiance, you want to call your friends, you want to report your teacher, but everything is done by the bot, and bot actually mimic your voice, okay, with everybody in a different tone, means how the way you talk with a mother, this is called as a prompt engineering in artificial intelligence. Okay, how you talk with your mother, how you talk with your sister, with your fiance, with your friends, with your teacher, the way of your talking changes with everybody, and in the same way it's talk with them, it sends the message, everything it's doing, and at the same time it's reporting it to you that you have done this thing at this time, this is the chart and everything, you just have to look, you are not doing anything, you are doing your work. Okay, so this is what we call as a AGI, because it is working on a different domain at the same time. I think you got a brief idea of this, because AI is still in its baby stage. It is not yet completely developed, but maybe in 5 or 10 years, due to the advancement in technology, we may get the AI to the point that we will find the artificial human or humanoids, actually the robots working as a what we can say maid in our houses. Okay, they can do the very small things in the houses, like cleaning, washing, dusting, and like this, and that at the same time communicating the people, cooking, means in many things. These things are right now in flow of the research. I think you got the answer. Are you
Yes,
satisfied?
sir.
Okay, so we actually discuss what is heuristic, what is decision making, and what is the role of this heuristic function and decision making in artificial intelligence. Now, next thing is that from where all these things start, because when we discuss all these things, okay, now many of you may think that sir is not where is the Python, where is the Java, where is these things, man, Python, Java, all these are just the languages. If you don't know the mathematics, which is the language of engineering, okay, knowing any other language in the world, I'm saying knowing any other human or computer language in the world other than mathematics, not going to help you make any machine learning or artificial intelligence, what we can say, research in a proper way, because without knowing this proper statistic you can't stand the artificial intelligence. Artificial intelligence, three things required to be very clear in your mind. First thing is mathematics. If you don't know the mathematics, I say that you should have to go first to the mathematics class, complete it, revise it, and then come to the statistical elements, then comes to the machine learning and data science, and then only you will go to the AI. Otherwise AI won't help you. It is just out of the reach of your understanding. Mathematics is the only language which can give you the inside of the AI. That's why I'm having this next slide for giving this, that from where these heuristic functions actually come. The most popular heuristic function is this. This you know as AB square equal to BC square plus CB square, that is our Pythagorean theorem. Okay, now if you want this Pythagorean, see the distance of P to Q, if I make the square root of this, if I make the square root of this, so this 2 is cancelled, this 2 is cancelled. So d of pq equal to square root of q1 minus p1 square plus q2 minus p2 square. This is called as the Euclidean distance. This is called as the Euclidean distance. This Euclidean distance plays a very important role in every automation system that you are having in the world. Any automation system, if they are not following the Euclidean distance, they are simply not actually working. Okay, so it's all start with your right angle triangle given by the Pythagoras and the Pythagorean theorem, and this Pythagorean theorem is the first heuristic function which was simplified by the Euclid and to give the Euclidean distance. Now what this Euclidean distance, it is used in simulated annealing, where we actually calculate the entropy of the things. It used in hill climbing algorithm. It is used in many heuristic algorithm. Now in hill climbing algorithm, this is the P position, okay, the initial position, and this, if you go in this direction, this is the Q position. So this P minus Q, this, if it is plus, okay, P minus Q, if it is plus, okay, if it is negative, it's not okay. Okay, so it goes onward, and this is your distance. So what happens here, how the goal is reached, whenever they give this P minus Q is equivalent to 0 or epsilon. So this is used in hill climbing. Now what is hill climbing? Hill climbing is just like your this conveyor belt. An object is actually climbing towards a goal, towards particular goal, and a goal is checked. It is satisfying that particular goal, okay, it can go forward. If it won't, it will be thrown out of this belt. So this is where you use this. Now the next distance or next heuristic function that we use, again I am saying it is a Pythagorean theorem, but this distance is also called as a taxi cab distance, or this also called as a city distance. This was actually first created, actually computed in the city of Manhattan to reduce the impact of whatever radioactivity was there, and so they created a square block and they make the straight ways. And so this square block actually, if you have such type of square blocks, these square blocks abstract the things properly, means if you have this thing, and these distances were calculated by this. So how they calculated the distances? They simply cancel this square, all these square were cancelled. Okay, so they're saying that is d of pq is q1 minus p1 plus q2 minus p2, and to avoid the confusion they also added the absoluteness. So you get this q1 minus q2 minus p2 on this on the graph. So what we got, the Manhattan distance. Again, this is what the Pythagorean theorem simplified. Pythagorean theorem simplified, because this p2 minus q2 actually give you this distance between these 2 points p and q. Okay, so when we get these distances, actually can be used to make our system things in terms of. Now let's say, suppose I'm just giving now this, but these are quantitative in nature, and many times when we get the object, we get the qualitative in nature. Now what is p minus q then? Let's say, suppose you have the potato. Potato have certain features: color brown, okay, then shape undefined, and we can say the weight. Is it edible? Okay, yes. Now you have the potato as a p. So you have the brown color, undefined shape, and what you can say, the fruit, that is weight, and likewise. Now you are given with tomato. You are given with the tomato. So tomato color not brown. Color not brown. Then you get the other shape. Generally it is defined round shape. Okay, and here you are having some other so it is edible, yes, edible, but we know that these two matches. Okay, this not matches, this not matches, and only this matches. So if you give the weightage to this 1 to these qualitative features, the quantitative weightages in statistics, what we get here, these two terms which won't matches, they produces 0. Sorry, these two terms which won't matches, they produces the 0. Yeah, this color won't matches, shape won't matches, produces the 0, and you get what, only edible as a 1. So you got this distance which is equivalent to 0. You can't call this as a edible, that is one thing, but you want to find out the distance from potato to tomato, you will get a very large distance, because two things won't matches. So you got the distance as a 2, which is larger than the 0, and that we are giving with this q1 minus p1. So when we say q1 minus p1, you actually get here, let's call this as a 111, and here you get the features number as a 0, 0 and 1. Okay, so if you can make this using the similarity index, these distances can be calculated. Here you will get 1 0 as a 1, here you will get the 1 0 as a 1, this 1 1 you get the 0. Okay, if we go calculate, if you calculate like this, that is 0, 1 comes here, then you get 0. Okay, then 1 comes here and you will get the 0, carry on, and you get carry 1 here. Okay, carry discarded, you got no match at all. You got no match at all, and this is the way this PQ actually works in the model. You require to do the programming for that. Okay, in the basic strategy, generally what happens, the many of us simply go to this scikit-learn and other libraries, and when we go to these other libraries, we use the predefined model. Okay, those model are tested and everything is okay, but how those model works actually inside, if you don't know that those things, it is very difficult to, what you can say, define and design the proper way. So this is the one thing. Now there was one mathematician called as Minkowski. He actually generalized the Euclidean and Manhattan distance. Minkowski is considered as the one of the great mathematicians. So it simply said that is d of pq. If you want to generalize the equation, and if you make these 2 instead of k, k dimensional. Okay, because Manhattan and other distances there. You want this, so you just make absolute. This is q1 minus p1 raised to power k plus q2 minus p2 raised to power k. Take the absolute of this, okay, and make the power 1 by k. Obviously you get the complete summation of this. So this equation, which is called as a Minkowski equation, where the Euclidean and Manhattan become the special case of Minkowski. These are the basic heuristic functions. These are the basic heuristic functions which are used in automation, decision making, mostly in unsupervised learning and in this thing, uh, what we call mostly in unsupervised learning and also in reinforcement learning. These are also used in ensemble learning, which is weak intelligence. But when these are used in a different way, we can use it in for different things. This thing. So this is what my presentation. I have taken a very small presentation because this is a mathematics. If anything is left, I'm literally sorry for that. I would like to cover it up afterward. You can visit my YouTube channel. You can also for the TutorASRumale, where I'm already having 1.6k subscribers. You are free to subscribe. I'm also having one channel on spirituality and Bhakti Dhara, and on Udemy I'm having a free course, introductory course on machine learning right now, and going to upload the few new courses in Udemy by the end of this year, this academic year actually. So with this I would like to say thank. If you like my presentation and this lecture, kindly put a comment. Don't forget to write the mail. And if you require any type of help in artificial intelligence, machine learning, literatures regarding literature, regarding books, regarding some topics, something, or you are interested to do some research work in collaboration, you are welcome. Thank you very much for listening me so patiently for this long. If you are having any queries, questions, or any thing that you would like to share with me, please.
Okay, thank you, sir. Good afternoon to our respected Dr. S Rumale, sir, and all dear participants. I, Professor Akshata Thakre, I would like to convey thank you to our today's expert for sharing their valuable knowledge with us. As like sir explained, heuristic function and decision making AI. Also, I would like to thankful to all the participants. Now, with the permission of our today's expert, I declare the end of today's first session. For today's second session, join the second link 2 p.m. sharp. So, thank you, sir.
Thank you, madam. Thank you very much.